5.2 question number 9. So remember, this question number 9 is very important, right? Let's do E now. Can you see 81? So when you look at this 81, I'll try to find the factors, alright? Then I'll have 9 9s are 81, which means I can write it as 9 into 9, or simply as 9 square, which I have written here, right? If you look at the denominator, same thing with 25 again. So we have 25, which is what? 5 5s are 25. That means I can write it as 5 into 5, or simply as here in exponential form 5 square. Okay, so once I've done that, now I'll have a look at the numerator and denominator. 5 to the power 3 divided by 5 to the power 2. Division is there, right? Which means I can subtract their power. So you can see here 3 minus 2. These 2 just leave it, 2 to the power square leave it. Then again, if you look at 9, right? 9 to the power 2 divided by 9. So remember, 1 is here. Again, they're division, right? Which means I can subtract their power. So 2 minus 1. Then 3 minus 2, 1. 2 minus 1, 1. Right. Now once again, so remember, okay, this 9 to the power 1 and is equal to 9. It means the same thing, right? So I have here 9. If I try to find the factors of 9, I'll have 3 3. So which means I can write it as 3 into 3, or 3 square, which I have written here. Alright, so we'll stop here because this is our textbook answer. Let's do F also. Once again, if you look at this 49, I'll find the factors, right? So it'll be what? 7 7s are 49. So I can write it as 7 into 7, or 7 to the power 2, or 7 square, right? Once again, 16. So if I try to find 4 4s are 16, that means it will either be 4 into 4, or I can write it as 4 square in exponential form. Once we're done with it, let's start dividing. 4 to the power 3 divided by 4 to the power 2. Same base, different powers. I can subtract the powers, right? So 3 minus 2, these 2 leave it, and again 7 square divided by 7. Once again, 1 is here, right? So they have the same base, different power, which means I can subtract their power. So 2 minus 1. Then 3 minus 2 is 1. 2 minus 1 is also again 1. So once again, 4 to the power 1 and 4 are same. Clear? So now let's find the factors of 4. If I find the factors of 4, it will be 2 2, which means it is 2 into 2, or 2 square. Right. So if you look at the second number again, it is 2 to the power 3. Right? They have the same base, different power. It is multiplication, so I can add their power. 2 plus 3, and then there's I'm going to get the answer 2 to the power 5 into 7. You can write 1 if you want. Alright, 2 to the power 5 into 7, or 7 to the power 1, whichever you prefer. Alright. Alright, question number 10. Let's look at A. They have the same base, different powers. Same base, different powers. That means I can add their powers, right? So 49 plus 42, 38 plus 53. And when you add these two, I'll get 91. When I add 38 plus 53, I'll get 91. You can see this is plus, the other is minus. They're same, right? One is plus, the other is minus, so I can subtract them simply, and my answer will be 0. Alright, now this question is it's very important, alright? They've given us 10 to the power 5. If you look at 10 to the power 5, the first, and I try to find the factors of 10, okay, I can write it as 2 and 5, right? 2 into 5. See this style, okay? So my A is 2, my B is 5. Remember, they have the same power, right? Therefore, bracket 5, right? And if I separate this, I'll get what? I'll get back this one, right? Which will be 2 to the power 5 into 5 to the power 5, right? So for now, I'm just splitting this 10 into 2 parts, 2 and 5. Same thing I'm going to do with 6. If I try to split 6, it will be 2 and 3, right? Which means I can write it as 2 into 3 to the power 5. Alright, 1 is 2, next is 3, right, to the power 5. Now this can also be simply written as 2 to the power 5 into 3 to the power 5, just like this. Alright, so here the second step, I'm just keeping them together, 2 into 3, right? So now the next step, we'll be getting this 2 to the power 5 into 5 to the power 5. That means I've opened the bracket now. Okay, so I'll get 2 to the power 5, 5 to the power 5, and then 3 5 into 5 square is already there. Same thing, I'll open the bracket, so I'll get what? 2 to the power 5 into 3 to the power 5. Clear? So once we're done with the 2 to the power 5 divided by 2 to the power 5. So if there is division, I'll subtract the powers, right? So you can see here 5 2 to the power 5 minus 5. Now let's do 3 also. 3 to the power 5 divided by 3 to the power 5. Same base, different powers, so I can subtract their powers. Now the last, have a look here, 5 to the power 5 multiplied by 5 to the power 2. So you can see same thing, right? Same base, different powers. That means I have to add the power. So you can see here 5 plus 2. But can you see here below again 5 to the power 7? That means it's divided by 5 to the power 7. And when there's division, subtraction has to be there. So you can see here minus 7. Alright. Now 5 minus 5 is 0. 5 minus 5 is 0. Then this is 7 minus 7 is also 0. And we already know if it is 2 to the power 0 into 3 to the power, no matter what, right? If the powers are 0, our answer is always 1. So 1 into 1 into 1, my answer is going to be simply 1. Alright, the last question, question number 11. Express the following as a product of powers of their prime factors, right? So we have to find their factors, right? So if I try to find the factors of 54, then 2 2s are 4, 2 7s are 14, then 3 9s are 27, 3 3s are 9, then 3 1s are 3. So in place of writing 54, I can write it as 2 into 3 into 3 into 3, which I have done here, right? So you can see here that what there's only 1 2, right? So just 2, but how many 3's are there? There are 3, so 3 to the power 3. All right, same thing with 96. Let's find the factors. 96, then 2 4s are 8, 2 8s are 16, then again 2 2s are 4, 2 4s are 8, then 2 1s are 2 2s are 2 6 are 12, then 2 3, and then I can't go anymore, right? So which I've written here for us. Then how many 3? 3 is just 1, right? So 1. How many 2's are there? 1 2 3 4 and 5, so 2 to the power 5. Now keep them together, right? So 54 is how much? 2 into 3 to the power 3. 96 is how much? 3 into 2 to the power 5. So you can see this 2 and 2, right? 1 is 2 to the power 1 multiplied by 2 to the power 5. Same base, different power, I can add their power. So remember, 1 is here, so 1 plus 5, same thing. When you look at 3, 3 to the power 3 into 3, so 1 is here, right? They have the same base, different powers, which means I can add their powers. So 1 plus 5, 2 to the power 6, 3 plus 1, 4, so 3 to the power 4. Alright, the last question, same thing again here, okay? We have to, let's find all the factors of these two first. So if I try to find for 324, let's start with 2. 2 1s are 2 6 are 12, then 2 2, and 2 8s are 16, 2 1s are, right? Then 3 to the 6 3 7s are 21, then 3 9s are 27, then 3 3s are 9, and then 3 1s are 3. How many 2? 2 of them, right? I've written. And how many 3? 4. Right? So 2 to the 2 square into 3 to the power 4. Same thing. Let's find all the factors of 576. Then 2 2s are 4, 2 8s are 16, 2 8s are 16, 2 1s are 2 4s are 2 4s are, right? Then 2 7s are 14, 2 2s are 4, then 2 3s are 6, 2 6 are 12, 2 1s are 2 8s are 16, then 2 9s are 18. I'm going to have here 3 3s are 9, and then 3 1. Then how many 3's are there? There are 2, right? So you can see here. And then how many 2's? 1 2 3 4 5 and 6. So I've already written for us here. All right, so in short I can write it 2 to the power 6 into 3 to the power 2. Then when I multiply these two, 324 is this, right? So I've written here 2 to the power 2 into 3 to the power 4. And what about 576? 576 is 2 to the power 6 and 3 to the power square. So same thing, 2 to the power 2 multiplied by 2 to the power 6. They have the same base, they have different power, which means I can add them. Right, same thing again. Same base, different power, I can add them. Then 2 plus 6, 8, 4 plus 2, 6. So my final answer is going to be 2 to the power 8 into 3 to the power 6.